Hello cloud experts and fellow learners. Welcome to module 1.2 of AWS Certified AI Practitioner Certification Bootcamp. In this module, we will explain AI/ML fundamentals, algorithms, learning types, and module optimizations. Let's review the course outline. We will start today's session with machine learning workflow. Then we will review a couple of machine learning algorithms and the algorithms that you should know for this certification. Followed by, we will review supervised learning and we will discuss classifications and regressions algorithm. Followed by, we will concentrate on unsupervised learning. In that module, we will discuss clustering, dimensionality reduction, and anomaly detection unsupervised machine learnings. Then, we will review semi-supervised learning. And then we'll end today's session after explaining reinforcement learning. Throughout the course, we have used real-life examples and animations to make this session effective, interactive, and easy to understand. If you encounter any challenges or have trouble understanding a concept, please note down the timestamp and leave a comment. We will try our level best to clarify it for you. If you feel that these sessions are too lengthy or too short, please let us know your feedback as well. We'll adjust the session duration accordingly. If you are new to our channel or haven't subscribed yet, we'd like to request your 15 to 20 seconds to like this video and subscribe our channel. Liking or subscribing may not be a significant effort for you, but it motivates us. This video is a part of course series. If you want continuity and follow the content sequentially, please click the bell icon to get notification for any new topics. We are uploading the pending modules and we will update the course as AWS will update the course curriculum. We have a lot to cover today. Let's jump right into it. We'll start with machine learning workflow and the first step to identify the data sources. We can have different type of data sources and it can be real-time streaming data. In terms of real-time streaming data source could be IoT sensors. Like if you have temperature sensors, if you have room cameras, or if you have security cameras, or maybe GPS tracker. Real-time streaming could be social media APIs, that is data from platforms like Twitter, Facebook, or Instagram. It could be financial market trends, that is real-time stock, forex, or crypto market feed. Or it could be website clickstream data, or maybe your network security log or security alerts. On the other hand, we can have some batch processing data sources. Some example could be enterprise data warehouse, where we can have structured data from platform like Amazon Redshift. We can have historical transactional data. You may have an e-commerce platform where you have transactional data for more than 5 years. Or maybe you are absorbing medical or health record from government institute, or maybe some public data sources, or maybe from EHR systems. Now, once we have identified the data sources, the next step is data collection and storing the raw data. For data storage, you can use a data lake or even you can use Amazon S3 bucket. Now, to collect the real-time streaming data, AWS provides multiple services and here are some options. You can use Kinesis data stream or Amazon Redshift streaming ingestion, or maybe you can use Amazon managed streaming for Kafka. Whereas to collect the batch data, you can use AWS data pipeline, or you can use Kinesis data firehose, or even AWS Glue. Now let's assume that we have those data connectors which is used to collect the data and we have the raw data. Now once we have the raw data, the next step is data ETL. Data ETL involves data cleaning, data validation, data formatting, data proofing, or data versioning. Maybe you are receiving data in multiple different formats. Some are .txt format, some are JSON format, some are in time stream format. However, you need an uniform format for this machine learning training or even inferencing. If you remember, we talked in our previous lesson, garbage in, it will give garbage out. That is why you have to make sure your data is cleaned and it is well formatted. Now, once we have completed the data cleaning, we have the clean data, and that we have generated from the raw data. Now, you can store that clean data into a different bucket or into a different segment of your data lake. Now, a clean data can be even broken into multiple sets. Like if you remember, for machine learning training, we can break the set to training set, which will be roughly 80% of your total data set. Then you can have a validation set, which will be roughly 10% of your total data set, and then the test set. If your model is already trained and if you want to generate the inferencing, then you can use the data as input data to the model. Now, the next step is model engineering, where you need to train the model, and while training the model, you need to do the model tuning, that is the hyperparameter tuning. Maybe change in learning rate, maybe change in number of epochs, how many times you want to iterate the data set. And once the model is trained, we call it model engineering. The next step is model evaluation. And in this evaluation process, we evaluate the model with certain criteria, and then we select the model which is the perfect model for our use case. Once the model is selected, the next step is model packaging. And packaging means you can have the code, you can have the configuration, and we are packaging for model deployment. And in this case, we can have different versions of the model. After packaging, now we are performing model deployment, where we will perform the build or integration testing. And then after the deployment, we are going to set monitoring and logging. And this monitoring and logging for continuous monitoring if the model performance is drifting over time. And based on that, we can create a feedback loop. And the feedback loop, again, it can go to our data ETL process and adjust the data set based on the model performance. So this was on a high level, the machine learning workflow, the steps related to data source identification, raw data collection, then performing data ETL and creating clean data. These are called data pipelines. For model engineering, model evaluation, model packaging, model deployment, these steps called ML pipeline. Once you combine monitoring and logging with machine learning pipeline, then it becomes ML ops or machine learning ops. Now let's review some machine learning algorithms and models. We'll start with transformer model, which is a popular large language model. Transformer models are used to understand and generate human-like text. It can also be used to translate sentence, maybe from English to French, like you have written, how are you? And you want to translate that to French, like comment vas-tu? And you saw ChatGPT can easily do that. Or maybe you have given a paragraph and you want a text summary. Or maybe you have written one line and you want to continue in the same format and complete the paragraph. So this kind of task can be easily done using a transformer model. In terms of example, we already talked about ChatGPT. ChatGPT full form is Chat Generative Pre-trained Transformer. And Google Bart is another one transformer model which used in language translation. The one capability that outlined these transformer models that they are able to process a full sentence instead of processing word by word, and that is why they are so powerful. Now I will try my level best to explain how transformer models works, because these are some complex model. Let me try with an example. Let's say we have the text, the cat sat on the mat, and we want to feed this text, and maybe we want a translation from English to French, or maybe we want a summary of this. Now let's see how the translator model will work. The first step is input processing. In this input processing, transformer will take the text data and it will break down into smaller pieces or smaller fragment. It's called token. So once the input processing layer worked, we'll get a bunch of tokens, and you can see the cat sat on the mat, the sentence broken into small fragments like the cat sat on the mat. These are all individual tokens. The next step is input embedding. Each token will be converted into a numerical representation or vector that will capture the meaning. Now let's assume that cat will become 0.1 and 0.2. These are just numerical representation if we want to represent in a two-dimensional graph. However, the input embedding will be multi-dimensional, but as I mentioned, I am trying to explain with the help of simple example. After the input embedding, next step is self-attention or attention mechanism. And this is the core of the transformer model. It will help the model to focus on the different parts of the input text to understand the context and the relationship between the words. In our example, the model looks a sentence and it will decide which words are important. From the sentence, the cat sat on the mat, it might focus on cat and mat to understand the main idea, because cat and mat, these are the two main idea that it might find in the attention mechanism phase. The next part is layers of processing. That model has several layers and each layer refines the understanding. The first layer, it might understand that cat is an animal. And the next layer, it might understand that sat is an action. So it will try to understand what is the verb, what is the noun, what is the action versus what is the object. It will try to understand, and it has multiple layers. That is why the feed forward will come into picture. So layer 1, it will process, then it will pass that information for the next layer to process. And as I mentioned, it will have multiple layers to process that entire request. And the final step is output generation. If we requested to create a translation, then the output layer will generate the translation of the input text. If we have requested to create a summary, it will create summary. And if we request to continue the sentence, it will also do so. In this slide, we'll talk about another one machine learning model, which is diffusion model. Diffusion model is responsible to generate image from text prompt. Now let's break down how diffusion model, especially stable diffusion, work in a very simple way. There are two steps. First, forward diffusion. In the forward diffusion process, the system gradually adds random noise to the image in multiple steps until it becomes completely noisy and unrecognizable. So here we have the original image. The system will add little bit of noise, slight noise, some more noise to a moderate state, then high noise, and finally it is completely noisy and we won't be able to understand that image. The main purpose of forward diffusion is that it will help the model to learn how images degrade with noise. The next step is learning reverse diffusion. In reverse diffusion, we will start with a noisy image and the model learns how to remove the noise step by step, gradually reconstructing the original image. In the reverse diffusion process, the model will start with a complete noisy image. From there, high noise, a little bit outline on the image, then remove some noise to a moderate state where you will see those picture outline, to a slightly noisy state where the picture is almost done with a little noise until the final image. And the main purpose of reverse diffusion is it will teach the model how to generate new images from random noise. And this training process will help the model understand the structure of image and how to reconstruct from a pure noise. Now, once the model trained, at the generation step, if we put a text prompt, generate an image of a dog sitting on a beach, then the model will start with a noise or completely noisy image and then it will use the learning of reverse diffusion process to generate the final image. And if you are using the same prompt multiple times, you will not get the same image. Maybe next time you will get an image of a different pose of a dog sitting on a beach. And this is how diffusion model works. Stable diffusion is powerful because it can generate detailed and high resolution images, and it can carefully control the noise removal process from the image. Next, we will review multimodals in GenAI, where these models are not responsible for any specific type of task. It can do multiple tasks. Let's review some examples. It can generate image from a text prompt that you have already seen. It can also create video content from text script. It can combine text, image, audio, and it can generate output of a video and audio. Maybe you can feed text file, static image, and audio of a person, and you can request to generate a deepfake video for that person. GAN or Generative Adversarial Network is one of the example of many multimodal availables. And now let's review how GAN works. GAN is a combination of two neural networks. One is generator and the other is discriminator. The generator creates new data instance, and you can imagine this is just like an artist which is creating realistic paintings. Whereas the discriminator, this is again a neural network. It evaluates the data. You can consider it's like an art critic who judges whether the paintings are real or fake. During the training process, the generator and discriminator are trained together in a competitive setting. The generator tries to create realistic data to fool the discriminator, while the discriminator will try to get better by distinguishing the data is real or fake. Let me take an example. Let's say the task is to generate image of a lady. The generator creates the image and the discriminator checks if that look like a lady or not. Next is the feedback loop. The feedback loop has two steps. One, the generator improvement. When the discriminator correctly identifies a fake data, it will provide feedback to the generator on how to improve. On the other hand, the discriminator improvement, when the discriminator is fooled by the generator, it will learn from the mistake and it will get better by spotting the fake. It's an iterative process. Training and feedback, it will take place in multiple levels of iterations, and then finally the prediction. GAN can be used in multiple different applications. It can create realistic images such as faces of a human or animals or even landscape picture. It can also be used in art and music creation. It can generate additional training data for machine learning model. Let's say you have a training data set and that data set is missing some representation, or maybe you need to generate some more data. GAN can help you in that case. In this slide, we'll review the name and purpose of some more machine learning model that you may come across in the examination. You don't have to understand how this model works, but you should know what are this model and what are the use cases at high level. To start with, first GPT, that is Generative Pre-trained Transformer, which is the main driving model behind ChatGPT, and GPT can generate human-like text or source codes. Next is Google BART. BART is bidirectional encoder representation from transformers like GPT, but it can understand the context of words in a sentence bidirectionally, and it can be used in language translator. Then SVM, Support Vector Machine. This machine learning algorithm used for classifications and regressions. We will cover classifications and regression in next slides. Then WaveNet. WaveNet can generate audio waveform and it can be used in speech synthesis application. Next is RNN or Recurrent Neural Network. Recurrent Neural Network used in speech recognition, time series predictions, etc. etc. Then next is ResNet or residual network. Residual network used for again image recognition, object detection, facial recognition. And then GAN. GAN we already discussed in the previous slide. GAN can be used to generate synthesis data, and it can be helpful in data augmentation process for machine learning. And last but not least, XGBoost or extreme gradient boosting. Gradient boosting is a powerful machine learning technique that is used for regression and classifications. The main purpose of XGBoost is to enhance the performance and speed of gradient boosting models. So this was the all models you should know on a high level for the AI practitioner exam. Next, we'll review supervised learning. In supervised learning, model is trained on label data. That means data includes both the input and the correct option. If I'll explain with an example, this is just like teaching a child with flashcard. We first show the child a card with picture of an apple and tell him or her that it's an apple. After showing many such label cards, the child learns to recognize which is apple or which is other fruits. The similar analogy applied here. Let's try to understand how supervised learning works, and we'll take an example of creating a machine learning model to recognize spam emails. We have label dataset. In that label datasets, we have some email which is marked as not spam versus some emails which are actually spam. And we have the machine learning model. Now, once we'll train the model with this label data, and after training, model might create some kind of relations or correlations between those emails to identify which one is spam versus which one is a not spam. The machine learning model may come up with certain characteristics, like if the email has some words like free, win or prize, then it can be a potential candidate for a spam email. Once the model is trained, now if we feed the new incoming emails which are not labeled, then the model will generate the predictions or inferences, and it will distinguish the emails which are spam versus which are not spam. Next, we'll review classification. Classification is a type of supervised learning where we used to predict the categorical variables of output. That means here output variables is discrete and it will fall into one of a specific category or class. If you remember the previous example of identifying spam versus not spam emails, that was a perfect example of classification. Let's assume we have two different new emails, one with subject line win a free prize and the email 2 with a subject line meeting at 10 a.m. Now, once the model is trained, it can correctly classify the email 1 as spam and the email 2 is not spam. One point we'd like to highlight, the outcome should be always discrete or to a specific category. That means the email either can be classified as a spam or not a spam. There is no third status in between. There are some more use cases for the classification. If you want to predict whether a patient has a breast cancer or not, if you want to predict whether a credit card transaction is a fraudulent or a legit or not, if you want to predict whether a loan application will approve or deny, or if you want to classify image of corpse to detect diseases. So these are all different use cases or examples of classification model, and you can clearly see here the output will fall into one of the category. It cannot have a continuous value. In this slide, we'll review another one supervised learning technique which is called regression. Unlike classification, in regression supervised learning, we try to predict numerical values based on one or more input features. Let's take some examples. Maybe if you want to predict house price based on house size, location and number of bedrooms, then it's an example of regression. Another one example could be predicting the future price of a stock based on its historical data. Let's review regression modeling steps. The first step is data collection. In this step, we gather historical data with input features and corresponding output values. If you see this example, we have a collection of house size, bedroom, location, year of build, and the corresponding price for that house. So this we are going to use as an input data set for our model. Once we have the data collected, next step is data processing. In this process, we try to clean the data, we handle any missing values, and also normalize the features if necessary. If you review this example, here we have a missing line. And in the data processing, if we have any data with missing values and all, we can eliminate or we can add the respective values in that cell. For our example, we have eliminated. Then the next thing what we have done, we have year of build, and it has all those years. But that year of build does not seem like a very important parameters for our pricing. That is why we have calculated house age from that. So it's an example of feature engineering that we are going to cover in a separate section. Now, part of the data processing is we are preparing the data for model training. Once the data is prepared, the next step is model training. In training phase, we use the training data set to train the machine learning model. During training, the model learns the relationship between the input parameters and the outcome. For our example, it will be the house price. Post-model training, we perform model evaluation to assess the model's performance using statistical estimators metrics like mean squared error or R-squared. Using these metrics, we try to understand the difference between the predicted and the actual values. And let's assume that we have reviewed, we have identified that this is the perfect model for our use case. The next and the final step is prediction, where you use the trained model to predict outcomes of the new data. For our example, we have taken two records for what we want to predict. Here we have the house size, number of bedrooms, city, and the house age. Now based on that, the model will predict maybe the house 1 price is predicted around 5,500K and house 2 price is predicted around 320K. In the certification exam, you might encounter some use cases and scenario, and it will ask you to identify the machine learning algorithm like regression or classification. And if you see any use case to predict a category like email type is spam or not spam, then it is classification. But if the goal is to predict a quantity or a real value, then it's an example of regression. Now, if we will relate both regression and classification, in both the models, the data is trained based on label data to make the prediction. For email spam, in previous example we saw where we determine the category of the email, that is it a spam or not spam. But when it comes to regression, maybe we can predict the length or the time it takes to read. Now I hope you got a clear idea the difference between classification and regression, and you have to understand it by your heart because you will encounter some use cases where you need to identify where regression or classification is the perfect model to select. Next, we will review unsupervised machine learning algorithms. Unlike supervised learning, for unsupervised learning, we used unlabeled data. That is, for the data, there will be no tag or there will be no predefined values for those data. Let me try to explain with a real life example. Imagine you have a box filled with different toys, but they all are mixed up and you want to organize them into groups. You start by looking at the toys and noticing their features such as size, color and types. For an example, maybe cars, dolls, blocks. Without any prior labels or instruction, you begin to sort the toys into groups based on their similarities. And let's assume that you have sort the cars and the soft toys into two different groups. Now, as you sort, you might discover new patterns or categories that you have not noticed before, like separating the cards into small and large cards. By the end of this process, now you have organized the toys into meaningful groups based on their feature, even though no one told you how to do it. And this is a perfect example of unsupervised machine learning. Under unsupervised machine learning, the model discovers hidden structure and learn patterns in the data. In terms of benefit of unsupervised learning, we can discover hidden pattern in stored data. Maybe you have transactional data for last 10 years, 20 years, and if you want to discover any hidden pattern, this is the perfect use case. If you want to find structure in data without even predefined label, because when you have data in a bulk quantity, labeling the data is always not easy. Or this is ideal for data exploration or maybe exploratory data analysis. If you have any use cases for that, then unsupervised machine learning is the perfect candidate. Now let's review some common techniques or algorithm that we can use for unsupervised learning. The first is clustering, and the algorithm name is K-means clustering. We'll review all those algorithms and techniques in the following slides. The other technique is dimensionality reduction, and the algorithm name is principal component analysis or PCA. Maybe if you have a data set and you want to reduce the data set volume, or if you want to make the data set to a smaller fragment, then dimensionality reduction is the perfect technique. And the third is anomaly detection, and the algorithm name is isolation forest, and Amazon has their own proprietary algorithm called random cut forest. So these are some type of common techniques or algorithm we use for unsupervised machine learnings. In the following slides, we are going to focus on those clusterings, dimensionality reduction and anomaly detection, and we'll have a deep dive for all those common techniques. Let's review unsupervised learning clustering. Under unsupervised learning clustering, we group unlabeled data into K clusters based on the feature or similarities of the object. The algorithm we used for the clustering technique is called K-means clustering. Now you must be asking, what is the meaning of K? K will represent the number of clusters. Let's understand using a real life example. Let's assume a retailer, and the retailer wants to create targeted marketing campaign for each customer segments, and the retailer wants to offer personalized promotion and to enhance its customer satisfaction. This is my use case. Now to summarize the use case, what you want to do, the retailer wants to segment the customer into different groups based on the purchasing behavior they have. To start the process, we need data. Now we need customer purchase history, and that purchase history includes customer annual income, customer spending habit, and customer demography. Let's assume that we have some data. Let's say we have some customers, or let's say we have the data like this. Customer 1, he or she purchase cosmetics, the creams, and the trendy garments. Customer 2 purchases baby food, baby cosmetics. Customer 3 purchases grocery, laundry supplies, and also cosmetics. Like that way, we have all the customer purchase history. Now, when we'll feed the data into our machine learning model, which will drive with K-means clustering, it is going to segregate the customer into different segments. So after that, the outcome will be, it will group the customer into customer segments such as high spenders, budget shoppers versus the occasional buyers. And once the retailer will have the segment of the customers, they can target their marketing campaign or the offers based on their purchasing habit. Now we'll review dimensionality reduction, another one unsupervised machine learning algorithm. Dimensionality reduction used to simplify a dataset with many features for easier visualizations and analysis. Let's assume You have a huge data sets and there are many dimensions to the data sets. Maybe you have a table. In that table, there are many columns and most of the columns are not related to your use case. Dimensionality reduction will allow you to reduce or eliminate those columns which are not applicable for you. The algorithm used in this case called Principal Component Analysis or PCA. One of the use case could be, let's say a tech company wants to reduce the storage of high resolution images or video without losing any significant details. And I believe it's a common use case even for everyone in today's world. In terms of process, our data set is high resolution images that has many pixels. And let's assume this is one of the image what I have taken from internet. Next, the principal component analysis, the algorithm, it will reduce the number of features while retaining most important information. And if I will break it, one image can have multiple layers and every layers will have pixels as it is broken into this diagram. Now it will start analyzing each and every pixels and it will try to identify what are the areas it can crop or what are the areas are not required. Now the outcome or the end goal is we got a compressed image that require less storage space, but it will maintain the same visual quality. That means we are only reducing the size without even reducing its visual quality. The next unsupervised learning is anomaly detection. With anomaly detection, we try to identify unusual pattern or behaviors that are significantly deviates from the standard behavioral pattern. If you see in this diagram, our data set or our observation mainly lies between these two lines. If we see any observation which is far away from the normal, then it is a potential anomaly. One of the algorithms used in anomaly detection called isolation forest. Amazon also has its own proprietary algorithm called random cut forest. A common use case could be, let's assume a bank wants to detect fraudulent transaction in real time. And in terms of process, here my data set is all the financial transactional data that includes location, amount, time. Now if we try to understand here, let's assume person A every day he logs from San Francisco, maybe between 9 AM to 10 PM, and normally he trade an amount of, let's say, $1,000. If at one point of time, if he is logging, let's say from Philippines, or maybe he is logging around 2 AM at night, or all of a sudden he is performing some huge amount of transactions, that could be potential of a fraudulent transactions, because this is not or this is beyond the normal behavior. The isolation forest algorithm identifies all the transactions that deviates significantly from the natural pattern. This is one example of isolation forest graph that I have taken from internet. You can see this pattern or this transaction or this data point is far away from the regular patterns. That is why the algorithm detects as a potential fraudulent transactions. And the outcome could be all the flagged suspicious transactions could be go for a further investigation or review. And by this way, we are saving lot of manual errors because all the transactions not required to be reviewed. Only those flagged transactions need a human intervention. These examples shows how unsupervised learning algorithm can be applied to solve practical problems in various industries. I hope now you have a strong understanding on different supervised versus unsupervised learning techniques. Next we will review semi-supervised learning. Semi-supervised learning sits between supervised learning and unsupervised learning. We reviewed that for supervised learning, it uses only labeled data, whereas unsupervised learning uses only unlabeled data. Whereas semi-supervised learning uses both labeled and unlabeled data to train the model. One of the common use case could be a hospital wants to develop a machine learning model to diagnose cancer diseases from medical images. And in terms of process, they might not have all the label data. However, the hospital has a small set of medical images that has been labeled by doctors, that is the images which are labeled as cancer versus non-cancer. They also have a huge large set of medical images which are unlabeled or without any label. At the training process, we will feed both the labeled data and the unlabeled data. The labeled image will help the model to learn the correct diagnosis, whereas the unlabeled image helps the model understand the general structure and features of medical images. And now after the training, if we pass a new image, even if the cancer is in very early stage, the model will detect that as a cancer, and the outcome is the model can diagnose cancer even at very early stages. Next, we'll review reinforcement learning. Reinforcement learning is a type of machine learning where an agent learns to make decisions by performing actions in an environment to maximize cumulative reward. In this reinforcement learning, there are some key components. To start with, agent, the learner or the decision maker. It could be a robot or a game character. Environment, the world the agent is interacting. It could be the game board, it could be the maze. In terms of state, a specific situation in the environment, it could be the agent's current position or the robot's current position with rewards. Then action. Action is a move that the agent can make. That means it can move left, right, up, down, jump. All those moves can be taken as action. And finally, the reward. A reward is the feedback from the environment. For an example, maybe we can give treat to a dog if you are training a dog. If we are designing a game, then the positive feedback or the positive points or the coins, if the robot will perform the action what is intended to, or if it is performing some action which is going to block the wall or block the effort, then we will give a negative point. Let me break down the reinforcement learning for you, and I will explain with the help of a real life scenario. Imagine that you want to teach a dog to fetch a stick. In our case, the agent will be the dog. That means the learner is the dog. The environment, it could be your backyard where you are training the dog. The status, it could be dog's current position in the yard. The action, the dog can run, it can sit, or it can even fetch the stick. And the rewards, the dog will get a treat if it will fetch the stick correctly. Now in that process, the first phase is exploration. When the dog is not trained and the dog tries different action to see what works for it. Then the second is reward. A treat or a reward will be given to the dog if the dog will be able to fetch the stick. We call about positive reward. And next, the learning. It's a continuous learning process. Over time, the dog learns that fetching the stick leads to a treat and it's more likely to repeat that action. Now let's try to understand reinforcement learning with the help of a computer problem or a computer game. And for this case, now we will take an example of a maze game where the robot needs to exit that maze with highest point. In our case, we have the maze with an entry and exit point, and the robot is our agent. Now if we will try to map the key components of this game with the reinforcement learning, for our case, the agent is the robot. The environment is the game board. The state is the current position of that robot with the rewards it collected. In terms of action, it can move right, left, up, down to go to exit. In terms of reward, the robot earns point, and we can check if it will hit the wall, it can get minus 10 points. And if it will go to an unblocked move, it will get minus 1 point. In terms of process, first the exploration step or exploration phase, where the robot does not know how to start from this entry and go to that exit. It might start It might hit that wall, or it might move first to then hit the wall, or it might go move along and hit the wall and blocked here. By this way, robot will understand the best possible route to go to the exit. And in terms of reward, we have already discussed any unblocked move will lead to -1 point, whereas if it will hit the wall, it will get -10 points. And then over time, the robot will understand the correct path from entry to exit, and the robot learns to avoid obstacles and collect points to maximize the score. This was all for this module. Now let's review whatever we have covered in today's topic. We started with machine learning workflow. Then we discussed different machine learning algorithms and the must-have algorithm that you should know for this certification. We touched supervised learning. We discussed classification, regression. Then we moved to unsupervised learning, where we discussed clustering technique, dimensionality reduction, and anomaly detection. Then we covered semi-supervised learning and reinforcement learning. For the next module, module 1.3, we are planning to cover feature engineering and machine learning model evaluation. Happy learning and thank you for your time. Before we conclude this session, we would like to request you, if you are new to our channel or haven't subscribed, please subscribe to our channel and please click on the bell icon to get notification for any new modules. You can also review other video courses like cloud offerings, microservices, DevOps, and many other topics. Thank you again for your time. I hope to see you in module 1.3.